Today, we're diving into the fascinating science behind one of life's biggest puzzles: why teenagers seem to be completely wired for taking risks. It's a question that's baffled parents and teachers for generations, and it turns out the answer is deep inside the brain itself.
You've seen it, right? The impulsive choices, the search for a thrill, those moments that make you just hold your breath. Well, as it turns out, there's a really powerful scientific explanation for all of it, and it's happening inside the developing brain.
For the longest time, people just chalked this behavior up to, simple rebellion or just bad judgment. But you know what? Scientists are finding out it's not just rebellion. It's not just a phase they're going through. It's a phase their brains are literally built for.
Researcher Lawrence Steinberg, who's a huge name in this field, makes a really strong case that this isn't some kind of character flaw. Not at all. It's a completely normal, even predictable part of growing up. And the reason for it is all about neurology.
So what's the big idea here? Well, back in the late 2000s, researchers like Steinberg came up with this really compelling theory to explain why risk-taking peaks during these years. It all comes down to a kind of race happening between two different systems inside the teenage skull.
They gave it a name: the dual systems model. And the basic idea is this: two super important brain systems mature at totally different speeds. And that creates this temporary but really powerful imbalance.
Okay, so think of it like this. You've got the brain's gas pedal. That's the limbic system. It's all about emotion and feeling that awesome kick you get from excitement. In teens, that system is fully developed and super sensitive. But then you have the brakes, the prefrontal cortex. That's the part for impulse control and rational thinking. And that part, it's still seriously under construction. So what do you get? You get a powerful engine with really weak brakes. Not a great combo, right?
Okay, a supercharged gas pedal, weak brakes. It sounds good. It makes sense, right? But science needs more than just a cool analogy. It needs cold, hard evidence. So the question became, how do you actually look inside a brain and prove this mismatch really exists?
And that's where this landmark 2014 study comes in. A team of neuroscientists led by Sarah-Jayne Blakemore decided to go find it. They were basically on the hunt for the smoking gun, the real neurological proof for this dual systems model, hidden somewhere in a bunch of brain scans.
And I mean, this was a huge challenge. You can't just scan a few people one time and call it a day. No. To really track development, they needed to find people who had been scanned at least 3 different times, covering that whole crucial window from childhood all the way to early adulthood. And to top it off, that gas pedal, the limbic system, is buried deep in the brain, and it's notoriously tricky to get a good, clean image of it.
And get this wasn't all just fancy computers doing the work. The job of checking every single one of those scans for quality, it actually came down to 2 PhD students, Kate Mills and Anli Scottings. They had to go through them one by one with their own eyes to make sure the images were usable.
Yeah, the researchers put it plainly. This was meticulous, grueling work that took weeks. It's just such a great reminder that behind these huge breakthroughs, there are real people putting in hours and hours of tedious but absolutely crucial work. And for them, it was about to pay off big time.
So, the big moment. After all that work, they've got the data. They were finally ready to see if the evidence was there. What would the brain scans actually show? Was the theory about the gas pedal and the brakes actually right?
And the method was actually pretty brilliant in its simplicity. They decided to measure the volume of gray matter in these different parts of the brain over time. So they figured, okay, we'll call a brain region mature once its gray matter volume kind of levels off and stops changing so much. Simple, but very effective.
And what they found was pretty stunning. Their biggest finding was this: the prefrontal cortex, remember, that's the brain's brakes, saw its gray matter volume drop by a massive 17% between childhood and early adulthood. That shows this huge, long period of construction and rewiring. The brakes are being built well into your 20s.
And when you look at the whole picture, it just clicks. You've got the amygdala, which is all about emotion, pretty much mature by age 14. The nucleus accumbens, the reward center, it changes slowly but surely. But the prefrontal cortex, that's the one going through that dramatic, extended remodel. I mean, you can see it right there in the numbers. The mismatch isn't just a theory, it's staring him in the face.
So this was the moment, the smoking gun. These scans provided the very first direct neurological proof of the dual systems model. The gas pedal, that emotion and reward system, is absolutely ready to go way earlier than the brakes.
So, the verdict is in. The theory isn't just a good story. It's literally written into the physical construction of the human brain.
This developmental mismatch is a core feature of what it means to be a teenager.
So, let's break it down. What are the big takeaways here? First, that dual systems model, it's now backed by hard science. Second, this imbalance between a revved-up gas pedal and a still-developing brake system is a huge reason for all that teenage risk-taking. And this is maybe the most important part. This is all a totally natural, predictable, and temporary part of growing up.
And that brings us to a really big question, something to chew on. If we know that a teenager's brain is literally still under construction, that their ability to control impulses just isn't fully online yet, how does that change how we, as a society, should think about their choices, their mistakes? It definitely gives you a different perspective, doesn't it?